Muscle anatomy. We're going to look at the gross anatomy of muscle, and just for illustration purposes, we'll look at one of the quadriceps muscle, let's say the rectus femoris. Big muscle on the front of your thigh that helps to flex your thigh and extend your knee. So if you're looking at a little section of it, here would be the tendon attaching to the pelvis. A tendon always connects a muscle to a bone. And then similarly, surrounding the whole muscle is a connective tissue called the epimysium. You can take that word apart and see that epi means upon and mysium means muscle. It surrounds the entire muscle. And then within that, surrounding groups of muscle fibers, you have the paramysium. And that's an orange. And it surrounds groups of muscle fibers. And when I say muscle fiber, I mean a cell. I just was looking this up and found out that the rectus femoris has about 1 million muscle cells within it. So in my little drawing, I made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 muscle cells. Well, imagine instead that it has 1 million muscle cells. And then each one of those muscle cells is surrounded by what's called endomysium. Endo means inside. So there's packaging upon packaging upon packaging. If you were into recycling, you would say, hey, let's reduce all this packaging. Of course, all of this packaging is critical for healthy functioning of muscles. So it's not packaging you want to get rid of. And in every muscle you have fast twitch fibers and slow twitch fibers. And what that means is some of the muscle fibers respond with powerful and quick contraction, and others have a slower but longer lasting contraction. And these groups of muscle fibers are called fascicles. So let's try to put a So a fascicle is a group of similar muscle fibers, either slow twitch or fast twitch, or there's intermediate. And when you're exercising, you can recruit selectively different fascicles in order to contract. And you start off by contracting the slower twitch ones, and then as you try to get to a more powerful motion, you eventually can recruit the fascicles that are very fast twitch, but they tire out sooner. We'll talk more about that as we go along. What I'd like to look at right over here is what a motor unit is. Let's just turn my paper. So a motor unit is one motor neuron and all the muscle fibers or cells that it controls. So the rectus femoris may have, 800 motor units. And what that means is that it has 800 motor neurons going to it. And then you can recruit these selectively. So you could start recruiting motor units that have fascicles in them that are slow twitch fibers, and they're kind of a slower, longer lasting contraction. And then if you're trying to like kick a soccer ball and do something very powerful, you can recruit all of the motor units, including all of the really fast twitch powerful ones that wear out pretty quick. So each motor unit, let's go down here. Actually cross off the word each. So motor units control how many cells contract, right? If you have one motor unit, then you would have 1,000 cells contracting. If you had two motor units, you would have 2,000 contracting. Of course, if you got all the way up to 800 motor units, you're getting near on 1 million muscle cells contracting. And then what about how hard they're contracting, though? Well, that is a different topic. Events inside of each cell. How hard each cell contracts. And what that means is that as you get warmed up, you're still, sending electrical signals to all these motor units, but now inside of the cells, they're getting warmer, and their enzymes are working faster, and their contraction is more effective, and you can actually have a far more powerful lift, let's say, after you've warmed up than your first lift of the day if you're into weightlifting. That's this, and it's these two things, how many motor units are involved, and therefore how many cells are involved, and how effective each individual muscle cell is at contracting, that is able to give humans this very wide range. So we have a range of strength that we can apply from each of our muscles, and we can thank this great range that we have for the fine motor skill, for example, of me holding this pen and writing, versus the powerful muscles that my son is supposed to do when he does one of his taekwondo punches and is supposed to oomph with it and you really try to make something powerful. So we have fine motor skills and power from the same muscles, depending on how many motor units we contract and then how hard each of those muscle cells is individually contracting. I'm going to stop there, and then we'll go and look at the microscopic anatomy of these muscle cells in the next video.